right, so these are the review problems for the quarter two exam, all right, specifically the Python review problems. Now, the answers are all posted on Google Classroom, but this video is for if you're getting one of the questions wrong and you're trying to figure out why you got it wrong or you don't understand why the answer is what it is. All right, so let's go through this and see how we do. All right, number one, what is the output when the code below runs? All right, so we have a string here. Inside of that string is Roy G. Biv, and then we're printing out name with an index of 0. All right, so the important thing to remember here is that when you have a string, the first index is actually spot 0. So this is spot 0, 1, 2, and then there is a space here, so that space has the index 3. That's a character just like anything else. Uppercase G would be our 4. The second space would be 5. Uppercase B would be 6. I would be 7. And V would be 8. All right, so each of these characters has an index number, and they start at 0. So when I print out name with an index of 0, I'm really printing out an uppercase R. All right, when I'm printing out name index 0 plus name index 4 plus name index 6, all right, the plus is just going to stick all of those things together. And then if I go through my different index numbers, I can see that 0 is R, 4 is G, and 6 is B. So this is just going to print out R, G, B, all right next to one another. All right, this one says print the name, and then the index is the length of name minus 1. All right, so this is another good point to kind of consider, is that this string has 1, 2, 3, 4, 5, 6, 7, 8, 9 total characters. So when you run this code right here, what it's really going to be doing is it's going to be printing name, and then the length of name is 9 minus 1. So we're printing out index 8, which is the last character. All right, the last character is never going to be the length of the string because we start at 0. The last character is always going to be 1 less than the length of the string. So this would print out the lowercase v. All right. Next, we have if name index 1 is in A, E, I, O, U. So what this syntax does is it just checks to see if this character is part of this list. It doesn't have to match the entire list. It just has to match one thing in this string or in this list of characters. So we know that index 1 is the O. O is inside of this string or inside of this list. So this one is going to print out the word true. All right, so this one's going to be true. This one's lowercase v. This one's RGB. This one's uppercase R. All right, let's take a look at the next one that starts using loops. So S equals candy. Candy is delicious. Result equals an empty string. 4K in range from 0 to length of string. Well, actually length of S, but S is our string. So this is basically going to go from 0 to 1, 2, 3, 4, 5. So this is basically like doing a range from 0 to 5, which remember, when you do a range from 0 to 5, that really only gives you 0, 1, 2, 3, and 4. But that's perfect for us because, again, these string indexes start at 0. So 0, 1, 2, 3, 4 is exactly what we need. All right, now let's take a look at what's actually happening here. All right, we're saying S with an index of K plus result. All right, and then when the loop is over, we're going to print out what we get. So let's kind of just go through this one character at a time. All right, when the loop starts, we're going to be at index 0, which is a C. So we're going to be doing C plus result, or C plus the empty string, and that's just going to give us C. All right, then we're going to go to the next index in our loop, and we're going to be doing an index of 1. So now we're going to be doing A plus the C that's now being stored in the result. So that's going to give us AC. All right, the loop goes around again. We're now on 2. So now we're going to be doing N plus result, which we just said was AC. So that gives us NAC. All right, we go to the next one. It's going to give us D plus result, which we now know is NAC. So that gives us DNAC. And then last but not least, we're going to get to the end of the loop, which is going to be Y plus the result, which we now know is DNAC. So at the end, we're going to get YDNAC, or basically candy backwards. All right, so by flipping this and doing S of K plus result instead of result plus S of K, it just kind of reverses the string on us, and we end up with candy backwards. All right, so that would be our end result for that one. All right, now let's take a look at what happens with this one. All right, so we're using the same string, S equals candy, so it's going to have the same 0, 1, 2, 3, 4. All right, result is still the empty string, and we're using the same exact loop. So it's just going to work its way through the entire word. So this time, we're doing result equals S of K plus result plus S of K. So the very first time through the loop, K is going to be 0. So we're doing C plus the empty string plus C, which is basically just going to give us CC. All right, then we move to the next one, and we're doing A plus the result, which we now know is CC, plus another A, which is going to give us ACCA. All right, and then you can kind of see what's happening here. I'll still go through it, but now we're going to add N plus result, which is ACCA, plus another N, and then we're going to get NACCAN. And then we'll do the same thing with D, and here we have NACCAN plus D, and that gives us DNACCAND. So it's basically just kind of doing the word for backwards and forwards. And then we have Y plus our DNACCAND plus another Y. And that gives us our final result, which is the YDNAC and then CANDY. All right, so it's doing it both backwards and then forwards because we're putting it on both sides of the result. All right, notice though, it's only going to print out once. I'm showing you the steps so that you can see how it progresses, but it only actually prints out once because the print is outside of the loop. So this is just kind of the work to show you how it's being built. This is the only phrase that actually gets printed out for these two loop problems. All right, let's look at number 2. Given the function scramble below, what is printed if we call scramble? Isn't this fun? All right, so let's take a look at what's happening here, and then we'll figure out what it's actually going to print out. So we have a function. It's taking a parameter called plain text. There's a variable even characters, which is the empty string. There's a variable odd characters, which is also the empty string. We're setting up a loop. And this is the pretty standard loop we've been seeing. So for index in range 0 to length plain of text. So this loop is just going to go through the entire string that's passed to our function or whatever's in the quotes there. And then we have if index %2 equals 0. So reminder, this is our modulus operator. It's the one that tells us whether or not there's a remainder or what the remainder is. So this is saying, hey, when you divide by 2, is there no remainder? Basically, is it an even number? Because even numbers, when you divide by 2, have no remainder. So this is saying if the index number is even, add that character to even characters. Else, which implies that the index number is odd, add it to the odd characters. And then after the loop is over, notice that this is after the loop is over, we're going to take our odd character variable and combine it with our even character variable. All right. So let's kind of see what's going to happen here. And the way I'm going to do this is I'm going to put odd characters up here. Yeah. And I'm going to put even characters right next to that. And then I'm also going to put a spot for the index number over here on the left. All right, so at the start, everything's blank. Let's talk about what happens when the index number is 0. All right, well, when the index number is 0 and you divide it by 2, there's no remainder. So what that means is odd characters are going to stay empty, but even characters are going to get that uppercase I. All right. Then the index number is going to go to 1. All right. At that point, there is a remainder. So this one's not going to happen. And instead, this one's going to happen. So odd characters is going to get the S. And even characters is going to stay the same. All right. Then the index number is going to go to 2. All right. So the second index number, and again, remember, they start at 0. So I is 0, S is 1, N is 2. The apostrophe there would be 3. T would be 4. Don't forget the spaces are part of that string, so you have to number those. Each one of those has its own number, and you have to remember that you're counting everything. You're counting the punctuation, you're counting the spaces. Everything counts as a character. So with index 2, that's the N. So N is now going to get added to our even characters variable. All right, and then we'd go up to 3. All right, 3 was our apostrophe. So that's going to get added to our odd character variable. And then our even character variable would stay the same. All right, and we'll do a couple more of these. I'm not going to do the whole thing because you see the pattern at this point, but we'll do 2 more. So 4, again, is evenly divisible. So that is going to that's going to go into the even characters variable. So we've got S apostrophe, that part's staying the same. And then this is picking up that next character, which is a T. Right? And then I'm going to do 1 more because that one's the space, and I want to make sure that we don't skip the space. So S apostrophe, and then I'm just going to draw the space right there so that we know that it's there. And then this one would stay the same. So I'm stopping right there, but just realize that this would keep going. All right. And eventually, when you get down to the end, all right, when you get down to the very last index number, which is 14, because it's 1 less than the length of the string. So once you've gone through all of those index numbers, your odd character should be S apostrophe, then a space, HSFN, if you've gone through and done all of them. And then your even characters should be the uppercase I, N, T, T, I, a space, and then a U. All right. Now, once the loop is over, that's what's inside of odd characters, that's what's inside of even characters. Ciphertext combines those together, putting the odd characters first, the even characters second. Since ciphertext is what we're actually printing out, your final answer would be S apostrophe with a space HSFN, capital I N TTI space U. Hold on, I just realized that I forgot the question mark here at the end. Whoops, that was my bad. So this should have the question mark there at the end because the question mark is a character. It's the very last character, so it would be index 14. I forgot the question mark there. Sorry about that. But that would have a question mark there, and that would be part of your final answer here. All right, and the question mark would be on the even character side because it's index 14. All right, so your final answer there would have that question mark. All right, so again, sorry about that, but it is there now. I caught it. All right, let's take a look at the next one. Write a function called mixum that takes a string for input and creates and prints out a new string, which is the same as the input, but with a period after every character, including spaces. For example, if we pass it, we hold these truths, it'll print out that following output that just has a period after everything. Okay. So let's create our function. We're going to call it def mixum. So we're defining a function called mixum. It tells us it takes a string for input. So we've got to give it one parameter. And again, you can pick the name that you want for this parameter. So I'm just going to use text, but that could be whatever you wanted. Then I've got my colon. I'm going to create an empty string that I can use to build this new string that I need to make. So result equals an empty string. Now, for me, this one doesn't require me to only go through part of the string. It requires me to go through the entire string. So I'm going to use the simpler loop. I'm not going to use indexing. I'm just going to say for letter in text. All right, and this will go through the entire string, and this loop variable will get the letters or the spaces or the characters one at a time. All right, so I don't have to use indexing on this one because I'm going through the entire loop and I'm not making a range of numbers. I'm just saying for letter in text. All right, so that will go through the entire word. And then what I'm going to just do here is I'm going to say result equals result. All right, so this is kind of how we can build things one at a time, plus letter. All right, so that's a plus sign, not a T, plus a period. So that's just going to stick a period after every single letter. And then at the very end, when our loop is done, this one doesn't say to return, it says to print out. So we're going to say print, again, outside of the loop. So I'm reducing my indent. I'm going to print result. All right, but this would put a period after every single letter. Number 4, what would be printed to the screen if we were to run the following code? All right, so we've got a function called emphasis here. Result equals an empty string. For C in input string, so this tells us that we're going through the entire thing because we're not using any sort of indexing here, and that this C, this loop variable, will get each character in the string. So we're saying if the character equals a space. So if the character equals a space, we're going to build up our string, but we're going to start with a period and then add the character, which we already know is a space because it's right here. Else, result string equals result string plus C. All right. Then when the loop is over, we're printing out, we're adding a period to the end of whatever we got at the very end, and then we're printing result string. So here is us calling it with this string right here. All right, so let's actually just kind of go through and think about what would happen. So again, we won't do the whole thing, but we'll do part of it. So here's C, here's result string. All right, so the very first time we go enter the loop, C is going to be W. All right, W is not a space, so we end up down here, and all we do is add the character. So result string, which started at 0, is now also just going to be W. Next, we move to the letter E. All right, E again, not a space, so result string is now just going to be WE. All right, the next character is a space. All right, now C is going to have a space. All right, so we enter this if statement, and what we do is we add a period, and then we add the space. So our result string is going to be WE period, and then have a space after it. All right, then we're going to go through H, O, L, and D. So we're going to get WE, and then none of these are spaces, so they're just going to slowly build up our string. So again, that's a space, HO, WE, that's a space, HOL, WE, space, HOLD. And now finally we get to our next space, and we can see that what it's going to do is it's going to put the period first and then make another space. So what we can see happening here is basically it's putting a period after each word. Now, when we get down to this last word, there's no space, so we're not actually going to enter this if statement. All right, the string ends with the S, but that's why they have this period here at the end of the loop. When the loop ends, that's going to put in the period, so our end result is going to be we period space HOLD period space THESE period space and then TRUTS period. All right, so that's what this function would end up creating. Cool. Number 5, write a function num vowels that takes a string as input and prints out a count of the number of vowels, A, E, I, O, U, or U, found in the string. You don't have to worry about capitals. For example, num vowels, we hold these truths, the same string we've been using would print 5. Okay, so we're going to make this function. So we're going to start with def, like we do for all our functions. All right, we're going to go through and call it num vowels. All right. Again, it has an input as a string, so I'm going to call that input text, but you could call it whatever you want. And then I've got my colon. All right, this time we're keeping a count. So instead of having an empty string at the top, I'm going to create a variable called count and set it equal to 0. And then I can say, all right, for, let's use C this time for character. Or I'll just abbreviate C, H. I'm going to write it out. I don't know why. For character in text, all right, that's our loop that's going to go through everything. And then we can say if character in, And then we would just have to list out the variables inside of quotes. A, E, I, O, U. Put our colon in there to end our if statement. If it's true, if the character is in A, E, I, O, or U, we just need to make count 1 bigger. So we can say count equals count plus 1. And that's really all we need to do as far as like the code is concerned. And then when the loop is over, then we just need our print statement. So we don't print out until the loop is over and it's had a chance to go through the entire variable. But once it's over, then we can print out count. All right. Now, this is a perfectly acceptable way of doing this problem. What I'm going to do over here on the side is I'm just going to rewrite it using indexing so that you can just see how it looks different and have that comparison right next to each other. So the first part's all the same. I'm just going to redo the loop part. And I'm going to say for index in range 0, comma, length of text. I wish I had just a little more room. All right, but for index in range 0, length, let me just rewrite this up here so that it's not squeezed. 0, comma, length of text. All right, that's what goes down inside of there. And then again, you've got your colon here. All right, this just ended up way too messy even for me. All right, let's rewrite it. All right, so I'm going to use I instead of index to save room. For I in range 0, comma, length of text. Then I've got my colon. All right, so that would be my loop. Now, I is no longer the actual characters. I is now a number. All right, so I use that number as the index, and my if statement is going to look like if text of I. All right, I have this extra step where I'm now using this number as an index because it's not the character directly in A, E, I, O, U. And then everything else is the same. I'd still do the count equals count plus 1. All right, so again, you can write these loops in either way. It's just important that you keep them clear and remember that this one, the variable is your actual characters. This one, your variable is a number that we use to index and get the actual character. All right, so again, either way is fine, just two different ways of writing it. And I just wanted to have you see those right next to each other. All right, number 6. Examine the function love 6 and 12 below. For each call to the function, write which letters will be printed out. All right, so this is basically kind of reading through conditionals and just making sure that you can follow along with the conditional. All right, so the first one is called with 3 and 6. So what's going to happen here? The first if statement says if A is less than 6 and B is less than 6. Well, B is not less than 6, so this is not true. The next one says else if, or elif, A plus B is greater than 12. 3 plus 6, not greater than 12, so that one's not going to be true. Next it says else if A times B is greater than 12. Well, 3 times 6 is 18, so we can see that we are going to print out the letter C. So the C is going to get printed out there. Then the else gets skipped because this one was already true. Notice that print E is not indented, so that one is going to print out regardless. All right, that's going to get printed out every single time, no matter what. And then the last one says, if a minus b is greater than or equal to 6, print out f. Well, 3 minus 6 is not greater than or equal to 6, so that's not going to print out. Now, technically, these would all be on separate lines, all right, because each print statement is going to create a new line. So I'm just going to say technically, these would be on different lines. Okay. Next, we're doing the same thing, but we're using 5 and 5. So in this case, 5 and 5 are both less than 6, so we're going to print out the A. The rest of these are going to get skipped. We always print out the E. 5 minus 5 is not greater than or equal to 6, so we're done. Okay. 6 and 12, or 12 and 6. Sorry, the function is called 6 and 12. This time we're passing it 12, 6. So 12 is not less than 6, so it won't be this one. 12 plus 6 is greater than 12, so we'll print out a B, and then these two get skipped. We always print out the E. That's automatic. And this time, 12 minus 6 is greater than or equal to 6, so we would print out the F as well. All right, last but not least, we have 8, 0. So 8 is not less than 6, so we won't do this one. 8 plus 0 is not greater than 12, we won't do this one. 8 times 0 is not greater than 12, we won't do this one. So that brings us down to the else, because it's the only choice left. The E always gets printed out. And then 8 minus 0 is greater than or equal to 6, so we would print out the F there. All right, so these would be your outputs for those 4 different function calls. All right, number 7. Consider the function below that takes a picture as input. Suppose this function is called on a 2x2 picture below. The red, green, and blue color values of each pixel are shown. On the 2x2 grid below, mark the changes that will occur to the color values when Conundrum is run with this picture as input. All right, so let's take a look and see what it's actually doing. So it's using coordinates. So it's going through x from 0 to width and y from 0 to width. So it's looking at the entire picture. All right, because it's using coordinates, it first has to retrieve the pixel. So this is just retrieving the current pixel. Then we're specifically getting the red component. We're specifically getting the blue component. All right. Then we're saying if the red component is greater than the blue component, set the blue component to the red value. Otherwise, set the red value to the blue value. All right, so one way or another, the red and the blue are going to end up matching, and they're always going to match with whichever one is larger. If red is larger, they're both going to become the red value. Otherwise, that must mean blue is larger, so they're both going to become the blue value. All right, so if we look at this first pixel here, it's going to retrieve both of these. Blue is the larger value, so this one's going to get reset to R30. All right. If we look at this one, they're the same, which means this if is not true. So technically, it's going to change this, but it's going to change it to what it already was. All right, so to the user, it won't look any different, but the computer did go through and set this to 0. All right. On the next one, red is the larger value. All right, and again, because y is the inner loop here, whoops, I actually should have gone, I'm doing them in the wrong order. If I'm being technically precise here, technically this box would happen first, this box would happen second, this box would happen third, and this box would happen fourth. All right, because the x stays the same while the y is changing. And then when the x changes, the y goes back to 0 and then goes down again. All right, so technically this one should have happened first. This one would happen second, and this one would get set to 20. And then this one would happen less, and again, last, and again, because the red is greater than the blue, this one would get set to 40. All right, so at the end, they always match, and they ended up with the higher of the two values. All right. Number 8. Complete the function below so that it changes all whitish pixels in the picture to black. Use the distance function and assume a pixel is whitish if the distance of its color from white is less than 75. All right, so you use this, I think it was in lab 4, was all about the distance function and using that to kind of detect different colors and how far things were. It was the clock face was the first time that you used it. All right, so in this case, we have to go through the entire pixel. The entire picture. So I'm going to use the style of loop where we just say for px in get pixels, which is a built-in jest function. So this loop, the nice thing about this loop is px is automatically a pixel. All right, when we use this get pixels function, it returns a list of pixels. So when we go through that list with our for loop, px automatically gets assigned a pixel. We don't have to use the get pixel function. We can just work directly with px. So what I'm going to do is I'm going to retrieve the color of px, and I'm going to say, all right, color equals get color of px. So now I've saved the color of that pixel. I'm going to check to see if it's close to white, if it's white-ish. So the way that I do that is I use the distance function. And the distance function expects 2 colors. So the 2 colors are the color variable, which is the color I just got from the pixel, and then I'm always comparing it to white. And white is a key word in jest, so we can just say white and it's going to know what we mean. Like we don't have to create the variable white, it's already in there as a reserved word. So we can say if the distance between the color of the pixel and white is less than 75. All right. If it's less than 75, that means the color is white-ish, it's close to white. So we're going to set the color of that pixel. So we're going to set the color of px, and it tells us that it wants us to set it to black. And again, black is a reserved word, so we can just say set color to black. We don't have to do anything special there. Okay, so that would be this. Number 9 says rewrite your solution to the previous problem so that it does the same thing, but only to the right half of the picture. Now, because we are limiting the range on which we are examining, we can no longer use this get pixels style loop. All right, now we're going to have to go back to XY coordinates. So I'm going to set up 2 loops. I'm going to say for x in range. Now it tells me I only want the right half of the picture. So instead of starting my range at 0, I'm going to set my range at get width, which is a built-in function, of pick divide 2, which is the inner division so that it gets rid of any decimals. So this starts my range at the halfway point, and then my range is going to continue on to the end of the picture. All right, so I'm using this get width to say start at the halfway point, go to the end. So there's my outer loop. My inner loop is going to be the y's. Now I am going from the top to the bottom, so my y range can just be from 0, which is the very top, to get height of the pick. All right, so that sets up the loop that's only going to go through the right half of the picture. But now I have to do the extra step of actually retrieving the pixel. because this loop is no longer gathering pixels, it's gathering coordinates. So I have to do the extra step of saying px equals get pixel pick comma x comma y. All right, so that retrieves the pixel. Once I've retrieved the pixel, the rest of the program is exactly the same. All right, I can now say color equals get color of px. I can now say if distance of color comma white is less than 75, and then I can say set color of px to black. All right, so when you're going through the whole picture, this is easier because you can skip the get pixel step. But when you start targeting parts of the picture, you have to use the XY setup and then include this extra step where you actually retrieve the pixel that you want to change. All right, number 10, write a Python function called white corner that turns the bottom right corner of the input picture to white. This corner will be 100 by 100. You may assume that the image is larger than that. All right, hence use nested loops and picture functions, get width, get height, get pixel, set color. All right, so again, we can't use this style of loop because we're only modifying a small part of the picture. So we're going to use the same sort of XY loops that we did here. Now, to make my life easier, and I could have done this up top here, but I didn't, I'm going to add a little extra step on this one, where instead of continually using and writing get width, get height, all again and again and again, I'm going to add in an extra step where I just say h equals get height of pick, and w equals get width of pick. Now when I need to use the height and the width, I don't have to keep writing get height and get width. I can just write h and w, which is going to make my life a lot easier. All right, now remember, with a picture, the top left corner is 0, 0. So the bottom right corner is the width -1 and the height -1. And again, I say -1 because, again, if it's 100 wide, the pixels are 0 to 99. If it's 200 tall, it's 0 to 199. All right, it's always one less because you're starting at 0. So our loops are going to be for x in range, and then my range is going to be the width minus 100 because I only want to go back and make the box 100 by 100. So I'm going to say w minus 100 comma w. So I'm going to go 100 back, but then I'm going to go to the end of the picture. All right, and again, I don't have to do w minus 1 here because the range function automatically drops that last number. All right, so that, and then I'm going to say for y in range, and I'm basically going to do the same exact thing. I'm going to start 100 up, but then go to the full height. Now, because these are coordinates, they're not pixels, I have to do the extra step of saying px equals get pixel from the pick of comma x comma y. And then once I have that pixel, then I can use my set color and say set color of px to white. And again, white's a reserved word, so I can just use that directly. 11, write test code that you could use to test your function white corner pick and the previous problem on a picture in a file called shops.jpg. Save the resulting picture with the white corner to a file called output.jpg. So this is that's the sample code that you write pretty much every time you're testing your function. So it would just be something like, my pick equals make picture. And the name of the picture file was shops.jpg. All right, we've created the picture object, so now we're going to send that picture object to our function. So I'm going to call white corner, and I'm going to send it that my pick object that I just created. That's going to modify the picture, and then once it's modified, I'm going to say write picture to and then I'm writing the picture that I'm writing is my pick, and I'm writing it to output.jpg. All right, so again, you've done this hundreds of times at this point this year. Same thing, my pick equals make picture, call the function, and then write the result to an output file. All right, where does that bring us to? Write a function called loveRed. All right, that will maximize the red component of any pixels in the bottom left corner of a picture that has a color that is not similar to red. So basically, if there's not enough red, or the bottom left corner is not enough red, or isn't close to red, we're going to max out the red. All right. Now, it says the bottom left corner. All right. So if we look at the bottom left corner, that means we're starting halfway down and we're only going halfway over. So when we make our loops, all right, let's start with def love red. All right, and we'll call the parameter pick. All right, when we make our loops, the x is only going to go halfway over, so it's going to go from 0 to the halfway point, and the y is going to start halfway down. So what that's going to look like is for x in range, I get to start at 0, but I only go to get width of pick divide by 2. All right, and again, the double division just drops any decimals because range shouldn't have a decimal in it. Then in the y, because I'm getting the bottom left corner, I need to start halfway down. So instead of starting at 0, I'm going to start at get height of pick divide 2, and I'm going to go to the bottom, so that's just the get height of pick. All right, so now my loops are set up. These loops are giving me coordinates, not pixels, so I have to retrieve the pixel. So I'm going to say px equals get pixel from pick at the coordinates x comma y. So that retrieves the pixel. Right, I'm going to get the color of the pixel. So I'll say color equals get color of px. So now I know the color of the current pixel. Then I'm going to make my if statement, and I'm going to use my distance function again. So if distance from color to red, and this time it said is greater than 100. So I'll say greater than 100. So if the distance between the color that we're currently on and red is greater than 100, we're going to max out the red. So we do that by saying set red of px to 255, because that's the max value that we have. All right? And that's all there is for this one. So we've got the loop that's targeting the bottom left corner. We're retrieving the pixel. We're retrieving the color. We're seeing if its distance from red is greater than 100. And if it is, we max it out. If it's not, we don't do anything. That's why there's nothing else in the code. All right, 13. Complete the following function that turns the bottom half of a picture blue. All right, so we're turning the bottom half of a picture blue. Again, anytime we're not just going through the entire picture, we're going to have to set up our XY coordinate loops. So we can do, I've got a little more space this time. So because I've got a little more space, I'm going to take advantage of that and do the H equals get height of pick. And you can always do this. It's just like on this one, I didn't think I'd have room. So I just did it right in here and that works fine. This one, I've got a little extra room. So I'm going to take advantage of it and do H equals get height of pick. W equals get width of pick. That way, when I'm using them in my loops, I can just write H and W. So now that I've got that, I'm just going to say for X in range 0, comma, W, because horizontally, I'm still going across the whole picture. And then this is the part that's different because I only want the bottom half. I'm going to say for Y in range height divide by 2. So that brings me down to the halfway point. That's my new starting point. But then I go to the full height. All right. Again, because these are coordinates, I have to first retrieve the pixel. So I'm going to say px equals get pixel pick, comma x, comma y. And then this one, it tells me that it's blue. So I could go through and say set red to 0, set green to 0, set blue to 255. But I can also just use set color and say set color of px to blue. All right, and that'll work because blue is a reserved word. So I can just say set color of px to blue, and then I'm done. Now, 14 asks me to rewrite that, but changing it so the color is an input, so that instead of always being blue, I could specify the color that I wanted. All right, so if I rewrite this, I now need a second input inside of my function. It already has one input, the pick. It now needs a second input, the color. All right, so when somebody calls my function, it's not enough just to send it a picture. It now needs to send it a picture and the name of the color that it wants it to, shade. So first part's going to be exactly the same. H equals get height of pick. W equals get width of pick. Loops are going to be exactly the same because I'm still just doing the bottom half. So for X in range 0, comma, W. Y is going to be exactly the same. For Y in range H divide 2 by H. I still need to retrieve the pixel. All right, if I'm going to change it, I still need to retrieve it. So px equals get pixel pic comma x comma y. Now, the only difference here, it's really a very tiny difference, so I pretty much just rewrote the exact same thing, is instead of setting color to blue automatically, I set it to the color. And again, that color was specified by the user. So if they call the function like this, white gets plugged in here. If they call the function like this, blue gets plugged in here. If they call the function with orange, then orange would get plugged in there. Whatever it is, this is now a variable that's going to store a color name. And then instead of having a color name hard-coded in here, I'm using that variable to specify what I want. So pretty much exactly the same, just that one tiny little change. All right, that brings us to the final one. All right, it says write a function using nested loops that makes a 150 by 40 rectangle appear centered at the bottom of a picture. It's kind of hard to see on the photocopy, but basically I've got a 150 by 40 picture here that's being centered. All right. So the question is, how do you actually center it? All right, well, let's think about this. We know pretty easily how to get to the middle. All right, so the middle would just be the width divide by 2. So we can set up our loop to get to the middle very easily. If we want to have this box centered, we know the box is 150. So that means if we have this drawing down line here, there's 75 to the right of that line, and there's 75 to the left of that line. So we're just going to start our loop 75 before the middle, and we're going to end our loop 75 after the middle. All right. So let's set this up. We've got h equals get height of pic. And I've got plenty of room here, so I'm definitely taking advantage of it right now. Get width of pic. So again, when we're setting up our x loop, it's going to be for x in range. We're going to divide the width by 2. That gets us right here. And then we're going to subtract 75 from that. All right. We're going to end our loop at w divided by 2, but then we're going to add 75 to that. All right. So that means our x is going to go 150 pixels, which is exactly what we wanted. It's going to go 75 below the middle and 75 above the middle. Now, the y tells us that it wants us at the bottom of the picture. So if we know the bottom of the picture is the height, we just want to go 40 up from that. So we're going to start at h minus 40, and we're going to go to 40. Okay. Now again, these are just coordinates, so we have to get the actual pixel. So px equals get pixel of pic comma x comma y. So now we've retrieved the actual pixel, and then we're just setting the color. So set color of px to, what color did it say? Oh, it doesn't say, but the picture, if you can actually see it, is red. All right, so we're setting the color of that pixel to red, and that will make that little rectangle appear centered and at the bottom of our blue box there, or our blue picture. All right, so I hope this was useful. Obviously, if you have any questions or one of my explanations didn't make sense, just reach out. But you do want to work through all of these, or at least watch this, so that you're prepared for the test. All right. Have a great day. Bye.